Our topic for today is completing the square, but we're going to begin with a slightly simpler version of completing the square so that we can see what our aim is with this process. The first thing we're going to work on today is finding square roots. And if we are given a simple quadratic that doesn't have an x term all by itself, doesn't have a 2x or a 3x in it. Let's say we have 4x squared plus 10 is equal to 46. This problem is fairly simple to solve. It's fairly easy to find the roots of our quadratic, to find our x-intercepts, because we can simply isolate the x squared term. To do that, we're going to subtract 10 from both sides. That gives us 4x squared equals 36. I subtracted the 10 from the left. I subtracted the 10 from 46. Divide both sides by 4. So divide 4x squared by 4, divide 36 by 4. I get x squared equals 9. And then take the square root of both sides of the equation. But we have to remember that when we take the square root like that, since this was an unknown that we squared, we don't know if we squared a positive number or a negative number. So our solution here, x, could be either positive or negative 3. Every time we take a square root in this kind of a problem, we're going to remember to take both the positive and the negative square root. This gives us x-intercepts, or solutions, or roots, or zeros of our function of 3, 0 and negative 3, 0. Pretty simple process. The solutions, though, don't always come up with these nice integer numbers, so be aware of that. For example, let's say we have 3x squared minus 5 equals 25. If I use the same process to solve this problem, and I add my 5 to both sides, 3x squared equals 30, divide both sides by 3, x squared equals 10, and then take the square root of both sides. In this case, I get x equals plus or minus the square root of 10. Now, there's not a nice, neat integer square root of 10. So I'm going to write my x-intercepts here as the square root of 10, 0, and negative square root of 10, 0. It is far preferable in most instances, unless you're solving some real-life problem, that you leave those as radicals because they are exact answers, and not change those to some form of a decimal approximation. Another type of problem that we can solve with square roots that are just a little different from what we're going to solve when we actually use completing the square is if our problem is what we call a perfect square trinomial. And a perfect square trinomial is a quadratic that is of such a form that I can factor it into two identical terms. So this gives me a good example of that. X squared plus 4x plus 4 equals 25. This factors as x plus 2 times x plus 2. Well, if I have x plus 2 times x plus 2, it should be pretty obvious that I can write that as x plus 2 squared is equal to 25. Well, I now have my squared term isolated, which means I can take the square root of both sides of the equation. So if I do that, if you take the square root of a squared quantity, then you are simply left with whatever was squared in the first place. So the square root of x plus 2 squared is x plus 2, which is equal to plus or minus the square root of 25. Well, solving for x, x is equal to, subtract 2, negative 2 plus or minus the square root of 25, which is 5. Now this shows us that we have two solutions to this quadratic. The first solution, x could be equal to negative 2 plus 5, which would give us a value of 3, or x could be equal to negative 2 minus 5, which gives us a value of negative 7. So I have two x-intercepts here. My x-intercepts are 3, 0 if x is equal to negative 2 plus 5, or my x-intercept is equal to negative 7, 0 if x is equal to negative 2 minus 5. Right, so we were able to solve that through the process of taking square roots, because this particular one happened to be a perfect square trinomial. But what happens when it's not? That's where our process of completing the square comes in. So we're going to look at completing the square on a quadratic that is not a perfect square trinomial. It's not a very intuitive process. In other words, you kind of have to memorize the steps when you are completing the square. So we're going to start with a problem, x squared minus 12x plus 7 equals 0. And we want to complete the square for this problem. To begin this kind of problem, we rewrite our quadratic so that all terms with an x are on one side. We want the x squared and the x terms to be on one side, and we want the constant terms to be on the other side. So in this case, we're going to have x squared minus 12x equals negative 7. Remember, change sides, change signs. Now, the next step is find b squared over 2. Well, okay, this is how I look at this. You take the number in front of the x, 12, times 1/2. Cut it in half. Whatever value it is, cut it in half. So 12 cut in half gives me 6. And then you square 6. Square your answer. That gives me 36. So take whatever value is in front of your x, have it, square it, and then add it to both sides. Now, does it matter that that 12 was negative? You know, I didn't bring down a negative 12. I just brought down a 12 here before I halved it. It doesn't make any difference. I'm going to square it. So if I'm going to square this, it really doesn't matter if it's positive or negative. So 12 times 1/2 gives me 6. 6 squared gives me 36. And I'm going to add that 36 to both sides of my equation. So x squared minus 12x plus 36 is equal to negative 7 plus 36. I added 36 to both sides of the equations. Now, factor the trinomial. It should always factor as a perfect square trinomial. That's the whole reason we call it completing the square, is because we want it to factor as a perfect square trinomial, and it will. This factors as x, whatever this sign is. If this is a minus, this is going to be a minus. If it's a plus, it's going to be a plus. 6, and that's always going to be the number you had here before you squared it, squared, equals, and then I'm going to add these two numbers together, so 29. We now have a quadratic where we have the squared term isolated, and I can now take the square root of both sides. If I take the square root of both sides, it's going to let me solve for my x term. So square root of a squared quantity is that quantity, so I'll get x minus 6 is equal to plus or minus the square root of 29. Move the 6 over and I have my answer. X is equal to 6 plus or minus the square root of 29. If that radical will reduce, you should reduce it. In this case, that radical won't reduce, and so we are done with our problem. Now, it's not always where our first term is just an x squared. When that's the case, sometimes things get just a tiny bit more complicated. So let's start with a problem like 4x squared plus 10x minus 3 equals 0. We're going to start this problem exactly the same way we started before. We're going to move that constant term to the other side of our equation. 4x squared plus 10x is equal to, add 3 to both sides, 3. But here's where the difference comes in. I need to get rid of this 4, this coefficient of the x squared. So I divide everything in my equation by the coefficient of x squared. Well, when I do that, that leaves me with x squared plus 10 over 4x, and you can reduce that if you want to. I'll probably do that in the next step, is equal to 3 over 4. So I divided everything by 4, got rid of this coefficient for my x squared term. So now we complete the square. Take the number in front of x, coefficient of x, 10 over 4, your b value, have it. Well, that's 5 over 4, 10 over 8, but I'm going to reduce it. 5 over 4, square it. When you square a fraction, you square the top number, you square the bottom number, 25 over 16. So that's what I'm going to add to both sides of my equation. So x squared plus 5 over 2x, I went ahead and reduced that 10 over 4, plus 25 over 16. I added 25 over 16 to the left-hand side. Equals 3 over 4 plus 25 over 16. All right, for most of you, I probably don't have to review this, but very quickly, add these fractions together. It's 3 over 4 plus 25 over 16. I need a common denominator, which is going to be 16 in both cases. So I don't have to do anything to this one. But 4 goes into 16 4 times, and 4 times 3 is 12. So I have 12 over 16 for that fraction. To add fractions, we add the numerator, so 12 plus 25 is 37. Denominator stays the same, 37 over 16. So that means this side of my equation is 37 over 16. Now, we need to factor the other side. X, whatever this sign is, plus what we had before we squared it, 5 over 4. Squared. If you don't believe it, multiply it back out, FOIL it back out and see what you get. Take square root of both sides. X plus 5 over 4 is equal to plus or minus the square root of 37 over 16. And now all that remains is to solve for x. X is equal to negative 5 over 4 plus or minus. Now, when you take the square root of a fraction, you can take the square root of the numerator and the denominator separately. You never want to leave a radical in the denominator. So we need to take the square root of this 16. Square root of 16 is 4. Square root of 37 doesn't simplify, so we're just going to leave it as the square root of 37. And there are my solutions. X is equal to negative 5 over 4 plus the square root of 37 over 4, and x is equal to negative 5 over 4 minus the square root of 37 over 4. The process of completing the square.